All right, ladies and gentlemen, it is really important that you follow these steps to balance this particular type of redox equation, and that's one that happens in an acidic solution. In an acidic solution. You need to follow these steps as they're written, and then in one action, what you will do is balance for charge, so you'll balance the correct number of electrons, and you will also balance for mass. That's the regular balancing that you know how to do. So step one is to divide the equation into two half reactions, one for oxidation and one for reduction. When I did this example here, these are the half reactions. I took the entire reaction and I isolated just the oxidation part of it, and then I took the reduction and isolated just the reducing part of it. After you have divided the equation into the two half reactions, you will balance each half reaction, and you must do it in this order. You will balance the elements that are not hydrogen and oxygen first. Then you will balance the oxygen atoms, and the only option you have to balance the oxygen atoms is by adding a water. After you balance the oxygens, you will balance the hydrogens. The only option you have to balance the hydrogens is to add a proton where you need it. After that, you will determine the number of electrons, and you will balance the charge. If the number of electrons are not equal, you will have to multiply the entire half reaction by an integer so that the number of electrons are the same. And here's a note to you. Electrons are placed on the side of the arrow with the highest oxidation number. And when you're done, you're going to add the two half reactions and cancel species. When you're adding the two half reactions, you must have electrons on opposite sides. Otherwise, you've done something wrong. Okay. Here we go. Potassium dichromate, K2Cr2O7, is a bright orange compound that can be reduced to a blue-violet solution of chromium ions. Under certain conditions, K2Cr2O7 reacts with ethyl alcohol C2H5OH as follows. Balance this using the half reaction method. And we're going to do this in an acidic solution. So we are going to follow the directions that we just looked at in number 5. Step 1 is to determine the oxidation number of every single atom in the equation. I want you to, fortunately for us, the hydrogen ion is given, as is the chromate ion. If you'll notice, this is a net ionic equation, and we cannot break apart the liquid, the gas, or the liquid. I would like you right now to tell me what the oxidation numbers are for each atom in the CO2 and the H2O, and then I will help you out with these two. Could you press the red button for me for a minute?
Yeah.